Okay, so let's go over your homework from the weekend that was on page 638. I asked you to do numbers 1 to 5. So the first one says, calculate the electrostatic force between charges of negative 2.4, and then there's this weird symbol here. And hopefully you remember from grade 11 that's a microcoulomb. And this one is 2. And micro is times 10 to the negative 6. Okay? And so our givens, Q1 is negative 2.4 times 10 to the negative 6 coulombs, and Q2 is positive 5.3 times 10 to the negative 6 coulombs. And then it says that they are 58 centimeters apart, which of course you have to change to meters, so 0.58 meters. And it wants you to find the electrostatic force. So that's our equation that we learned on Friday. Fq is equal to kq1 q2 over r squared. Don't have to rearrange it or anything, just stick your numbers in. So 9 times 10 to the 9th Newton meters squared per coulomb squared times negative 2.4 to the negative 6 coulombs times positive 5.3 to the negative 6 coulombs, and then divide it by 0.58 meters, which you have to remember to square in your calculator. And when you do this, you should get an FQ of negative 0.340 newtons. And then of course you have to tell me what the negative means. You think back to Friday, when you have two charges that are opposite in nature, one's positive and one's negative, they're going to attract. So it's an attractive force. And if you remember how I told you to keep track of it, force of attraction is a negative thing, especially if you're a nun. Okay, or any of you that are in a relationship that experience a force of attraction to someone you shouldn't, it's definitely a negative thing. All right, number 2. Electrostatic force of attraction between two charges. One is, so Q1 is 4 microcoulombs. Q2 is negative 3 microcoulombs. And this time it's telling you the FQ and asking you for the K. And so it says the FQ is 1.7 to the negative 1 newtons. But it says it's a force of attraction, which means you have to put a negative on it this time. And this time it wants to know what's the R, how far apart are they? So KQ1, Q2 over R squared, but you're rearranging for R. So R squared equals KQ1, Q2 over FQ. So again, 9 times 10 to the 9th Newton meter squared per coulomb squared. And notice how it has units almost the same as our G constant, only it was Newton meter squared per kilogram squared, and this is coulomb squared. 4 times 10 to the negative 6, negative 3 times 10 to the negative 6, and then our force 1.7 to the negative 1 newtons. Now, for most of you, my money would be on you didn't put a negative on this F, and so when you got your R squared, it would be 6.6353, and it would have turned out to be a negative. And you would have done what all good physics students do. You probably dropped the negative and just took the square root. But really, you put the negative on the force because it's a force of attraction, so R squared works out to be positive. So no physics rules are broken in the world or math rules. And when you take the square root, you get 0.797 meters. Okay? So force of attraction, negative. All right, number 3 says, two identically charged objects exert a force on each other of 2 times 10 to the negative 2. If they're identically charged, this is going to be a force of repulsion. Force of repulsion, positive thing. So 2 to the negative 2 newtons when they are placed 34 centimeters apart. So R is 34 centimeters, or 0.34 meters. and it wants to know what's the magnitude on each charge. In other words, how big are they? Not if they're positive or negative, but just how big the Q's are. So we know FQ is equal to KQ1 Q2 over R squared. But if they're identical, then you could write this as KQ squared over R squared, and then rearrange for the Q. So it'll be Q squared is equal to R squared FQ over K. So R was 38, or no, 34. 34 centimeters, so 0.34 meters. F was 2 to the negative 2, which would be 0.02 newtons. And K, 9 times 10 to the 9th Newton meter squared per Coulomb squared. So you get a Q squared of 5.068 to the negative 7 coulombs, but then you have to remember to take the square root, and it's 0. Oh, no, I lied. That is Q. Shoot, sorry, wrote down the wrong line. Q squared is 2.5689 to the negative 12 coulombs. And so then you get 5.068 to the negative 7 coulombs, and that would be 0.5068 microcoulombs. Now, the question only asked you how big is it, but I would probably say, and what are the natures? Okay, so they would either, because remember when you take the square root, you get plus or minus. But it doesn't mean one's plus or one's minus. If they're identical charge, it's either both positive or both negative. Okay? Because it has to be a force of repulsion. It didn't say attraction. It's a positive force. So they have to have the same nature, either both positive or both negative. All right, number 4. Trying to figure out what line I'm on here. All right. So number 4 says 2 oppositely charged objects exert a force of attraction of 8 newtons on each other. So our FQ is 8 newtons, and it's a force of attraction, so of course it'll be a negative. I just need to bring the book closer so I can actually see what the question is. What will be the new force of attraction if the objects are moved to a distance 4 times their original separation? Okay, so you actually don't know the Q's here, but you don't need them. You can just do it logically. So QQ over R squared, and it says that's equal to negative 8 newtons. And then it says, what will be the new force of attraction if the objects are moved to a distance 4 times as far apart? So if you make R bigger, FQ is going to get smaller. If you make R bigger by a factor of 2, that 2 is going to get squared, so FQ is going to get smaller by a factor of 4. So in this question, we're making R bigger by a factor of 4, and that's going to get squared, so our new FQ is going to be smaller by a factor of 16. So it'll be QQ over, so it's like 4R, but when you square it, the top doesn't change, so when you square it, it becomes QQ over 16R squared, once it's squared. And this part we had said was 8, negative 8. So it'll be negative 8 newtons divided by 16, so the new force of attraction should be 1/2 of a newton, and it'll still be negative because it's a force of attraction. Okay? You can actually do number 5 the same way. And just before we do it, so this is like an inverse square law, and that means that as one gets bigger, the other gets smaller by a square of. So in number 5, it says Q1 is 6 microcoulombs, Q2 is negative 2 microcoulombs. We're going to run out of time here in a second. And it says originally F1 is 2 newtons. Okay? So the first thing you're going to do is it says touch them. And if you remember from Friday, when we touch them,